Okay, everyone. In this demonstration, I'm going to show you how to diagnose conjunctivitis using the PowerApps AI builder. My name is Jenna Bourgeois. I am an MCT since 2001. Been a Microsoft partner since 2001. And I've worked with the Dynamics 365 and PowerApps platform for several years now, going back to 2007, I guess. That's when I started with Dynamics, so 13 years. So the first thing we're going to do is when you go into PowerApps, here I have make.powerapps.com. I choose my environment, and then I'm going to select Build under AI Builder. Now you can see there's a number of different models that I could choose from. There's category classification, entity extraction, form processing, object detection, and prediction. And then you see some standard canned solutions down here. And what I'm going to do is I'm going to choose object detection because my model is going to be based on images. So I'm going to give a name to it. I'm just going to call it conjunctivitis. And you could select what kind of objects you want. Now I'm going to use common objects, which is going to allow me just to create the objects. You could select the objects from the existing environment if you had them created. But in this demonstration, we're just going to use a new object. So I'm going to select next. Now, this was confusing the first time that I came here. And so basically what you're going to want to do is you're going to want to add new objects here. So if you, what this object is what you're going to identify the images as. So what's going to happen is I'm going to upload a series of images. The images are going to be divided into images that demonstrate conjunctivitis. And I am going to have another group of images that's going to display those people that don't have conjunctivitis. And then this object that I'm declaring here is going to identify which one those images is. So for example, what I want to do is if I want to detect the difference between, let's just say has conjunctivitis and does not have conjunctivitis, okay? So basically what you're defining here is not to be confused with other entities that you might have in your PowerApps or Common Data Service, but basically here I'm going to declare what kind of objects that I want to determine based on the images that I'm going to upload. And you'll see how we do that in a second. I'm going to click next, and now I'm going to add the images. Now, you can get your images from a number of different places. In my case, I'm going to get them from the local storage, and I'm going to go down to my desktop. There's conjunctivitis, and you can see I have a whole series of images that are pictures of patients with conjunctivitis. So what I'm going to do is I'm going to select these. Now, I found by doing this, it was easier, frankly, to do these all the images. There we go. I'm going to click close. And now I'm going to click on add images again. Oh, well, let me just take a step back. Before I do that, let's make it really easy because you're going to confuse yourself later, especially when you're dealing with this kind of images. So I'm just going to start with these images. I'm going to click next. And now it's going to ask me to identify these objects. I'm going to click on this, and now I'm going to highlight the area of the focus. So I want to know, I want the AI to identify what's in this area to use for its pattern. So how AI works is it's going to identify a machine learning, it's going to identify a pattern of what's in that box. And then based on how I select it. So if I select it too narrow and don't cover the full eye, if I select it a little further, I might not get the kind of results I want, but I want it to be able to kind of focus in on that. So what I'm going to do is I'm going to tag this as has conjunctivitis, right? Now I click next, I'm going to go to the next one, and I'm going to kind of do the same thing. Now to make a good model, what you want to do is you want to get, you can see how the eye is shaped a little differently here. Maybe it's taken from a different angle. You want to try to get as many different variants as you can. And you can see on that one that the system has already recognized what I'm selecting within the picture. And so it was automatically trying to identify that. And you can see that if I don't select it right, I can kind of adjust it. Now I'm going to take this one, and I'm just going to select around there, say has conjunctivitis. And you'll see why I'm doing these in a batch, because when I get done with this one, so right now I don't have to like interpret between my sample data which has conjunctivitis and which doesn't. So if you do it in a batch like this, you upload all your photos that kind of represent the ones that have conjunctivitis and label all those. And then what we're going to do is we're going to come in and do this a second time, but the next time we're going to do it, it's going to have all of the photos that don't have conjunctivitis. Now this one's kind of a tweener, you know, compared to the other ones that we had. But we're gonna kind of show that one, and we'll see how it affects it. Now I'm going to take this one here, and we've selected this one because it had kind of a little different anomaly in there. And that's the machine learning to identify kind of a slightly different pattern. So the more different types of photos you have from different angles, from how it's situated, the machine learning will get a better result. If you pick a lot of things that are very identical, and then when you go to test it, if you upload a photo that doesn't reflect exactly the way that is, then it might not be as accurate. Okay, so you can see that we're going to hit done tagging. So now we've identified all the ones that have conjunctivitis. Now what I'm going to do is I'm going to go back. I'm going to click back, and I'm going to go add some more images. Now you have to have at least 15 images from each one, each category. And here I'm going to select all the ones that don't have conjunctivitis. And you may notice that in some of these, I've selected different races, for example. I probably should have put more with that had conjunctivitis, but I didn't really have a lot of good sample data from multiple races. But you want to do that because if you actually look at something like the eye, you're going to have different skin tones, you're going to have different shapes, and you want to be able to create the best image. So now I've uploaded my batch, and now you can see that it's very easy for me to start here and then just label the ones that don't have conjunctivitis. So I'm going to say does not have conjunctivitis. Now you could see that I can do a close-up, or I can even do something that's far away. Now this one I selected because this person actually has a cataract. But again, I want to strengthen the pattern that the machine learning is identifying. So in case somebody has cataracts, I don't want the machine learning to think that based on it being a cataract is associated with conjunctivitis. So the more different kind of images that you have, the better the pattern recognition is going to be. And you can go, as many as maybe 50 images if you want. And you can see I also select a couple different ages, because in this case that we're looking at the eye, the ages are different. Or I mean the eye has a different shape, perhaps between a younger person and an older person. There we go. Does not have conjunctivitis. That one. There we go. Does not have conjunctivitis. I got a couple more to do. We got a total of 15 here. So the key to the success on this is really on the success of your sample data. Like I say, you want to have a lot of variation. You can see that this child's eyes are slightly different than the other ones, and so that will help strengthen the machine learning model. Here we have another one. You want to make sure you got different colors and, like I say, different shapes, different positions. Like you could see the different angles. I've got things that are close-ups. I got things that are not close-ups. And I'm going to select this one. Maybe get a little closer in there. Now, I haven't really tested these eye functions with, only using pictures that don't have makeup, for example. Women use a lot of eyeshadow and different kinds of eye makeup. And I'm not 100% sure if that's really having an impact on any of these. In other words, like if I was using this in the clinical setting, would I have to tell the patient, look, when you take this picture, don't have any eyeshadow? But predominantly, the system will recognize that what I'm trying to test is really what's within the eye, as opposed to what's around the eye. Here we go. You can see this one, it kind of selected it very large automatically. It didn't quite know where the eye perhaps was in here. We're going to select this one. Got a couple more to do here. There's an older woman. Here's a man that has a cataract. Here's another one. And I think we got them all. So we have a total of 40 images. We're going to click done. That's quite a few. Now I'm going to click next. And now it's just going to summarize what we have here. So we're using the object detection. We use common objects. We have 15 that show conjunctivitis and 25 that do not have conjunctivitis, for a total of 50 images. And now I'm going to click train. Now it will take you can see the status here. It'll take a few minutes for the system to train that data. And when it gets done training, we're going to be able to see what the AI builder determined was its accuracy. So while that's training, I'm going to show you an example. This one is used for Kawasaki disease. And this one had a 90% accuracy. Let's see if the training is done yet. Nope, still training. It'll take a couple minutes for that to happen. Now, the accuracy is going